But if you tap on a speaker, it will generate a millivolt AC signal. All right, folks, welcome back to the show. And for those of you that are new, my name is Luke, and today we're going to be going over all of the different test settings on your Fluke 101. Now, I don't think a lot of people that watch the show understand that I'm a huge Fluke fanboy, and I follow them on Instagram. I think they're great, and I have invested in them myself. So with all of that being said, let's go ahead and hop into it. Anytime I move these leads, this meter is going to move around. That's going to drive me insane. Okay, we're going to use different leads because this sucks. Okay, see how these leads, I can move around and it doesn't move around the whole meter? Okay, now that our meter is not going to be flopping around in the breeze, I love Fluke. I don't like their leads. They're too stiff. All right, first setting, AC voltage. I would always prefer, if you are able to use a dedicated outlet tester. They're very inexpensive and you can just plug it in. This one tells me right off the bat, I've got these two LEDs illuminated, telling me that my hot and my neutral are reversed, and it's also giving me the voltage present here. You're not always going to be able to do that though, and I totally understand that. So we're going to get into how you would figure that out with just your meter. We're on volts AC. It's letting us know that it's auto ranging. Can use our leads to open the little doors to our outlet. Okay, we're showing 120 at the outlet, but we have no indication that the hot and the neutral have been reversed for this outlet. So how would you determine that with your meter? You're going to need a ground. So you'll have to either run a lead from the panel or from somewhere else in the house where there is a ground so that you can do this testing. Because with just the hot and the neutral, because the voltage and current are flipping back and forth, we don't have a good idea of who's hot and who's not without a ground. So what I can do to start to figure this out, I'll leave one lead in one slot, take out one lead and put it to ground. And here we can see a very small difference of potential, only about 100 millivolts, which is like nothing. Then I can put this lead back, take this lead out, and now I can put it to ground, and now I'm getting my 120. So between my ground and whatever this is, I have 120 volts AC difference of potential. This lead is plugged into the left-hand side when it should be, my hot should be over here on the right-hand side. So that's telling me that my hot and my neutral are reversed. Now, if you don't get any kind of reading and you're trying to do this, you could have a faulty ground. So something to think about. All right, volts DC should be pretty straightforward. Red to positive, black to negative. And we're getting 13 volts. Now, unlike with volts AC, the polarity of my leads does matter. What happens if I do them backwards on accident? We're going to see here that we get a negative sign, and that's telling us that the flow is in the opposite direction of what the meter is anticipating. On old analog meters, it would have pegged back to just 0 and it wouldn't have showed any voltage. Luckily with our digital meters, it says, hey, there's still voltage here. We just have our leads swapped around. Pretty easy. This is really interesting that they would have selected this out of all the different settings they could have had on here. This is just for millivolts AC. So I was a little hard pressed to find, this is such a weird specific setting for a meter at this price point, and I'm trying to understand why they selected millivolts AC, or millivolts DC would have been a better pick. I was trying to come up with something that I could use as an example for this. And the only thing that I could find readily available around the house would be a speaker. If you don't know, speakers and microphones are very similar in principle. But if you tap on a speaker, it will generate a millivolt AC signal. Yeah, I think the only other thing that I could find that would have been useful for millivolt AC, like in industrial instrumentation, millivolt AC would be great. Motor sensors will also be, so like, I think even a wheel speed sensor would be an AC millivolt signal. I need to spend more time working with AC millivolts so I can come up with better examples. But there you go. I mean, it's just a small amount. Millivolts AC. There you go. Okay, resistance, diode, and continuity. You know, when we're measuring resistance, we just want to be cognizant of our units of measurement. Are we in mega, kilo, or just normal ohms? So if I have an M at the top right of my screen, take that value and times it by whatever's displayed. So 1.45 times a million is 1,045,000 ohms. And then if there's a K up there, take my value, times it by 1,000, so that would be 9,970 ohms. Something to look out for, you're gonna be really confused. Continuity, that can be great for just checking, it's a basic circuit check. Do I have continuity? Okay, I do. What about even just for a motor? Yeah, got continuity. Are my leads good? My personal favorite for continuity is identifying wires. Where does the red wire go? Doesn't go there. Oh, it goes there. Where does my black wire go? Goes there. Are these shorted together? Gives you a lot of information really quick. And then we can go over to diode. I've got a stripe on the right-hand side of this diode. I'm going to put my red lead on the left-hand side, black lead on the right-hand side, and that's the amount of voltage drop that we're getting. That's 0.536 volts or 535 millivolts. And then we'll test it in the other direction. And we should see that OL. That OL is standing for open loop, or basically not a complete circuit. Electricity can't flow, can't backflow. Saying that diode's good. Then we have capacitance. Always want to discharge our capacitors before we test them for capacitance. Just make sure these are discharged really quick. There are relatively small amounts of capacitance here. This would be like an AC run capacitor. If you're curious on how to test that, you've got C, Herm, and Fan. C is for common because this is really two capacitors built into one, right? And they share this C terminal. That's why it's the common, because they both have it in common, right? And then red to Herm. Give the meter a minute to charge up, 35 microfarads. Then we can check the fan side. Comes back 5 microfarads and 35 and 5 plus or minus 6%. And then we have this little guy. This capacitor does have polarity, so you see a negative sign on it. We can put that to our black lead and then other lead to red. Again, give it a minute to charge up. .647 microfarads that's coming back with. And then we have Hertz and duty cycle. So Hertz and duty cycle is great if we're dealing with like pulse width modulation and we want to get an idea of what is going on with our waveform without getting out an oscilloscope. So we have two variables that they give us. Hertz is the amount of time something cycles from plus to minus or on to off within a 1 second period. So like the electricity that comes out of our wall here in North America is at 60 Hertz. And then duty cycle is expressed as a percentage. And let's say we do have a pulsing square wave, we'll want to know how long that square wave is on versus off, right? And that's what duty cycle will give us. This is like a 50%. It's on 50% of the time and off 50% of the time. Whereas an example like this would be like an 80-20, right? And it would be expressed as 80%. So I've got another little meter here that outputs a little square wave, and we can just check its Hertz and duty cycle. Give us an idea. Okay, this is coming back at 47.6 Hertz. So turning on and off 47.6 times per second. And then if I hit the yellow button, that gives me the duty cycle, and it's at just about 50% duty cycle. So there you go. There's the Fluke 101. Kind of a funky meter, kind of a little bit different, but I'm glad that Fluke decided to join kind of this price point. But if you all are learning this stuff, I've got a bunch of different shorts and videos on a bunch of different meters to help you out. If you got any questions, comments, or concerns, go ahead and let me know, and I'll check you on the next one.